This is our supplier management lecture on MBW7, and today we will be talking about a concept called make or buy decision making. Make or buy. In short, MOB. So, erstmal eine Einführung, eine Introduction in the process of carrying out business activities. Of an organization a component, product, or service can be made within the organization or can be bought from a subcontractor, from a supplier. So when we have an organization, we can either try to produce it ourselves, make, or we can decide to get it delivered from a supplier, and then it's buy. Okay, so in any given situation, the organization should evaluate each of the above make or buy decisions, alternatives, and then select the alternative which results in the lower costs, lower knowledge loss, because if you decide to buy a product, you lose your knowledge. Okay, if you decide to give your drawings to a supplier so that they supply it for you, and you lose your knowledge, and your knowledge can be going to your competitors. So the lower cost is not the only factor to be taken care of. and so on. So that there are many factors in the long run. The make or buy decision is not static. The make option of a product may be economic today, but after some time it may turn out to be uneconomical to make the same product. For instance, i.e. Demand changes. As the demand changes, or demand goes down, then it is not profitable to perform the own production of the product, or supply chain becomes unstable. Imagine there are geopolitical problems with Russia or with China, and it is not advisable to produce in China or in Russia. And for this reason, I decide to stop buying a product. I decide to produce it myself. So it's the decision is made opposite. Okay. Due to geopolitical reasons, and so on. So there are a couple things that make this decision unstable. Thus, the make or buy decision should be reviewed periodically. Let's say every year to 3 years. This is mainly to cope with the changes in the level of competition and other environmental factors. Okay. Questions? Any questions, please? So this was just a little introduction. Then we go into the criteria for make or buy. Criteria for make. So 1, the finished product or service can be made cheaper. Of course, cost is a big factor by the firm than by outside suppliers. It is usually so when we have a supply chain network. Okay, those are the suppliers and this is the company. Imagine we have a supply chain network. This is the material flow and this is the inventory in between. Imagine this is Mexico and this is China. They both deliver to a factory in the US, and the US factory delivers to a factory in Germany. Okay, and this triangle is just inventory in between, as we have seen before already. Okay, so and now think about supply chain. Think about the time it takes to supply. So the factory in Germany sends its demand to the factory in the US, and then it takes around I don't know, 2 weeks for the ship to deliver. So we have here 2 weeks. So whatever I told them to send me in 2 weeks or 2 weeks ago, I am getting now. Okay, and this is fact of the matter due to the nature, the physical nature of my supplier who is in the US. And the US is sending their demand to a supplier in Mexico, and they get supplied by truck, and it takes 3 days. And then the supplier in China is supplying also, is getting the information and is supplying by ship also to the US, and it takes 2 weeks. So demand variability at the final customer will derive automatically in more variability downstream. We know this as a bullwhip effect. Because the variability is increasing, increases. We saw that the other day with our case study and our demand amplification. Because variability increases, it means that the amount of inventory to keep the supply chain safe, so without stock out, increases. Because inventory increases, quality problems hit harder. Imagine I have 2 weeks inventory in the ship between the US and Germany. I have 3 days inventory in the truck, and I have 2 weeks inventory between China and the US. So I have around 5 weeks inventory only in my trucks, in the logistics. And now imagine I have a quality problem or I have a design change to perform. So all this inventory is useless. Okay. And this means that the cost is always increasing. So for this reason, even for all this reason, this is you know all this already. This is the Little's law. Little's law, meaning that work in progress divided by the demand is equals the lead time. You should know this already. Because this chain of thought is important, even when the cost per unit at the supplier smaller is than the cost per unit at the end customer, own firm, not the end customer, at own firm who is deciding, own facility. This does not mean that buy is better. We need to take all costs and risks under consideration. Logistics, quality, pam, pam, pam. Okay, logistics, think about bullwhip. Think about demand amplification. Well, bullwhip is demand amplification, so. Logistics is the bullwhip effect, and quality, think about Little's law. Okay, this is very important. I don't know how to put it. So, Very important, okay? So when we talk about cost in these make or buy decisions, we talk about overall cost and overall risk, not just the manufacturing cost. This is a very, very common mistake. Any questions so far? So second criteria, moment. Second criteria for this make or buy decision is that the finished product is being manufactured only by a limited number of outside firms which are unable to meet demand or flexibility requirements. Okay. It is important that you when you analyze a supply chain network, that you analyze the structure of the network. It is important that you analyze factors like the average path length, which in turn will be your lead time. It is important that you analyze factors like clustering coefficient, which are going to be giving you hints about what suppliers are dependent on other suppliers. It is important that you analyze factors such as EPI, every part, every interval, which is going to be giving you hints about the flexibility of the supplier. All these concepts should be known. If they are not known, please let me know. And we can go through them in a private conversation. Ja. Ja. Natürlich. Du musst nur auf die Webseite gehen, auf meine Webseite. So, for those, es ist alles online. Ich stelle das alles offen zur Verfügung. Du musst auf www.prof4.com gehen, dann auf dem jeweiligen Wintersemester oder whatever, so the semester when we saw it, and then just access the YouTube playlist. Das Beste ist, wenn ihr euch anmeldet auf dem YouTube-Kanal, okay? Und dann habt ihr das alles organisiert nach Playlists. So YouTube subscribe, okay, is for free. You don't need to pay, and you have then access to all organized to the list of playlists that that are in my channel, okay. But yes, everything is online. Everything is you can access everything. It's just everything is there. And I will not erase it, so it will be there in the future too. So I hope it serves the purpose of. At the end of the day, I want you to learn, so I make my information available so that you learn as much as possible. So that's the idea. So you want, in a supplier, you want your supplier to be meeting demand, of course, that they have the enough capacity, okay? And in order to perform a capacity check, you know what to do. Capacity, you need to look at the cycle time, in Deutsch Zykluszeit. Cycle time, you need to look at the changeover time, in Deutsch Rüstzeit. Changeover time, and you need to look at the whole process. Where do you have supermarkets and where do you have not supermarkets, and you have FIFO, and then decide where is the Schrittmacherprozess, step-making process, and then just decide how much inventory you have on each of the supermarkets, and so on and so forth. If somebody thinks that all the information we saw in the last semesters was not relevant or was only relevant for the semester, then think twice, okay? I will only make one exception, and this is the exception of Irena, because she has not been visiting the classes before, okay? She's new to the semester. So all this is going to be relevant when you dimension and when you make a decision, make or buy. Please make sure you go back to your notes and you try to understand holistically what we're talking about. So ich wiederhole es auf Deutsch. Die Entscheidung Make or Buy ist so wichtig, dass ihr eigentlich alles, was ihr bisher gelernt habt, in eurem Studium eigentlich zur Geltung kommt. Die Entscheidung ist nicht einfach eine Kostenrechnung, ich mache ein paar Zahlen und dann ist gut, sondern die Entscheidung muss eigentlich den gesamten Supply Chain betrachten. Themen wie Average Path Length, Clustering Coefficient geben Hinweise über die Qualität des Netzwerkes, denn EPI und die Berechnung von EPI ist relevant um die Flexibilität von den Suppliern dann zu ermitteln. Auch Kapazitätsrechnungen sind wichtig, wo ich den Cycle Time, die Zykluszeit und die Rüstzeit dann analysiere, oder die Berechnung, wie ich einen Supermarkt berechne. Okay? Ich werde lediglich eine Ausnahme machen, und zwar mit Irena, weil sie halt in den vorherigen Semestern nicht dabei war. Aber für die anderen ist halt natürlich, Irena, if you have questions or regarding all these concepts, just contact me, okay? And then we go through them, no problem. All these concepts are going to be relevant in this supplier management lecture. So any questions? The third aspect that somebody had a question here. Irena, du bist auch seit Beginn dabei? Wer ist dann neu? Who is new? I thought we had a external student. For some reason I thought it was Irena. There is one Austauschstudent und die Studentin, und diese Austauschstudentin wird halt dementsprechend ein bisschen anders behandelt in die Prüfung, aber der Rest nicht. Verständlicherweise, hoffe ich. So the part, the third criteria is that the part has an importance for the firm and requires extremely close quality control. So as we have seen in the past, quality feedback loops play an important role. Imagine we have a supply chain, a very simple supply chain of three factories, 1 to 3, okay? And then the factory 1 is supplying to factory 2, and factory 2 is supplying to factory 3. They are giving their demand to each other, and so on and so forth. So imagine that factory 1 has a quality problem. Okay. If we decide instead of performing making in 3, if we decide to buy from 1, then and then if 1 has a quality problem, then it will take the whole supply chain. This is a concept we saw before. It will take the whole supply chain to discover the mistake. As a result, it might be better for strategically important products. It might be important to decide to make rather than to buy when I cannot afford to have a quality problem because of the supply chain structure. Okay. The fourth and last criteria to make is that the part can be manufactured with the firm's existing facilities and is similar to other items in which the company has manufacturing experience. So if I have a product that is very similar to what I already do and doesn't take more knowledge or more changeover than necessary, and I can perform this production myself without incurring in a lot of investment, then it might be advisable to make myself instead of buying. Okay. The key of the matter is, or the nature of this game is always rooted on cash flow. Okay, cash flow. If you have your business here, like let's say this is your where you keep your money, and this is an allegory of your business where you calculate the money you have. The casa. Okay, there is money coming in, and there is money going out. You spend on suppliers, on the workforce and stuff. So the cash flow is equal to the money coming in minus the money coming out. Okay. Always remember that cash flow is more important than your mother. Okay. So cash flow rules, and if you buy, then you're spending money. If you make, you're also spending money, but you're also you're spending less money if you make than if you buy sometimes, or you're spending more money if you buy than if you make. So which trade, make or buy, makes the cash flow best? Okay, gives you a better cash flow. This is actually the question at hand. Okay, but not only product cost per unit, but overall cost per unit. Not only production cost per unit, but overall cost per unit. And this is important. Okay. So any questions, please? Please Fragen? So the criteria for buy. Criteria for buy is, let's say, one double. I'm gonna make another color. I don't like it. So this blue is nice. The criteria for buy. One. If the product requires high investment, on facilities which are already available at the supplier. Plant. Well, then it might make sense to think about buying. The company does not have facilities to make it and to make the product, and there are more profitable opportunities for investing the firm's capital. Remember the cash flow, okay, and the return on invest. Here we're looking at cash flow and return on invest. And these are all concepts that you should know. Okay, I just highlight them, but later on in the exam, I expect you to explain all this stuff in further detail and to apply it, as we will apply it later on in case studies. Because basically, the make or buy decision making is something that for you and for your future work is just crucial. Okay. Existing facilities of the company can be used more economically to make other parts the skill of personnel, people employed by the company is not readily available or adaptable, better said, adaptable to make the part, to make the new part. Fifth, patent or legal barriers prevent the company from making the part. Or six, demand is just seasonal. Is either temporary or seasonal. Okay. So it would be fair enough to say that there is a third way, okay? There is not only make or buy the product. There is also a third alternative, which is what? Somebody think about it? Yeah, yeah, yeah. Eine breakthrough alternative. You can buy the supplier. You can buy the company of the supplier. Okay? If you have enough or the necessary financial resources, or the bank trusts you, you can buy the supplier. Okay? If the product is strategic enough, and if the product is something that is going to be a breakthrough and you need it, and the supplier is a small firm that is just looking for growth, or you can just call the supplier's owner of the supplier company and just make him an offer for their company. Sometimes better, because then you buy all the patents and legal barriers are gone, and you preserve, you are blocking your competition to buy this product from the same supplier. So you are going to be avoiding a lot of legal problems down the road if you just buy the supplier. Okay? And this is something that is very, very common. It is sometimes even better to buy the supplier than to just buy the product. Okay, because if you make a if you turn if you turn into a buy decision with a supplier, you start involving him or her in the quality management, in the supplier management, and then this supplier is going to have your cash, and with this cash they're going to grow, and with this growth they're going to get more customers. Very, very possibly these new customers are going to be your competition, so you will be facing issues. Sometimes it is just better to buy your supplier. Okay, any questions so far? Well, then we make a little break and I send you another invitation in a couple minutes. Now, so far, do you have any questions? Okay, no questions. Feel free to interrupt if you have any questions, okay? So what approaches can we choose to perform a make or buy decision? What management approaches, okay, meant to be? The easiest, simplest is to make a simple cost analysis. We can make a more complex economic analysis, or we can make a break-even analysis. Okay, both, all three are possible, and we're going to see all three of them with 3 examples. Okay. So simple cost analysis. Imagine, okay, so we see all this with examples, okay? So I think it's the best way to learn. Imagine a company has extra capacity that can be used to produce a fixture which it has been buying for €900 each. If the company makes the fixtures, the parts, it will incur materials costs of €300 per unit, labor cost of €250 per unit, and variable overhead cost of €100 per unit. The annual fixed cost associated with the unused capacity is €10,000. Demand over the next year is estimated at 5,000 units. question is, would it be profitable for the company to make the fixtures? Okay. So is the question, the problem at hand, understood? Okay, good. We have been buying for 900 each unit. The company would have a cost of 300 plus 250 plus 100 euros per unit, plus a fixed cost of 10,000 associated with the unused capacity, and the demand is 5,000 units. The question is it profitable to buy, or is it profitable to make yourself? Okay. So the solution, cost to make. This is just a simple, the first most simplest way to solve it. Okay. So what is the variable cost per unit? Equals material plus labor plus overhead. Okay, just very simple. This is 300 all in euros plus 250 plus 100 euros. This equals 650 euros per unit. Okay, euros per unit. And the total variable cost is the variable cost per unit times the demand, the expected demand. Okay, and this means 650 euros per unit times 5,000 units in the year. Okay, and this means 32 wait a minute, I don't want to be making a mistake. 3,250,000 euros. Okay. So is that cool? I'm gonna change this to, I'm gonna change this number to 1 million, okay? €1,000,000. So the total variable cost is 32 million, no, 3,250,000. Yeah, and we are going to add the fixed cost, which is 1 million euro, to have with unused capacity and this delivers a total of 4,250. Okay. The total cost to make is 4,250,000 euros per annum. Any questions? Okay, cost to buy. We have the purchase cost, which is the demand times price per unit, equal 5,000 units times 900 euros per unit. This means 4.5 million, I think. 4.5 million. So add fixed cost with associated with unused capacity, unused. Unused. Unused capacity. Which is 1 million euro. This gives a total cost to buy of 5.5 million. Okay. Total cost to make, total cost to buy. So because the cost total cost make is smaller than the total cost to buy, then the decision is the organization should make the fixtures. Okay? You cool with that? Any questions? Any questions? Okay. The second approach is to perform an economic analysis. And for this, the following inventory models are considered. First, we have a buy or purchase model. And then we have a manufacturing model. Okay. So this is 2.1. And 2.2. Probably you remember from our previous lectures. And if you don't remember, we do it here now again. Purchase model, the EOQ model. Okay, in which we have a supplier. This is the demanded quantity. Okay. Sorry, this is the time. And this is the quantity that is supplied, and then we have a Q inventory level, and then we perform such scissor. Production is instantaneous, delivery is immediate, the demand is deterministic, demand is constant over time, production can run in fixed setup cost, and so on and so forth. So we have here several variables. D is the demand per year. P is the purchase price per unit. C sub C is the carrying cost. Per unit in year. C sub O is the ordering cost or setup cost. K is the production rate. Number of units produced a year. On R is demand in units per year. So we know from before that our curve if we paint Q, how much we order, the quantity order, and the cost. If we have a we have a Y of cost, okay, and then we say this is H. We use the holding cost. So this is A and this H. Okay. Setup cost is so this function is CO times D divided by Q. Okay, this is giving our setup cost plus some carrying cost times Q divided by 2. We know this because this is the average demand, Q divided by 2. Okay. Plus some constant, okay, C times D, which we are not going to represent. Production costs and so on, this constant we will not represent. So we have two curves, okay, as a function of D, one the setup and one the carrying cost. The more we order, the more inventory we carry. Okay, the bigger our queue, our Bestellmenge, our purchase model, the more inventory we carry, and therefore the more cost we have. So this would be the carrying curve, carrying cost. And the bigger our purchase order, the smaller it gets with the setup cost, because we only need to organize certain set of deliveries. So as a result, we end up with this curve, which we already know, in which the optimum is here and whose cost is optimum cost, the minimum cost is this one. Okay, so if we perform a partial derivation, as we have done before in the past, this ends up being this. So if we make Q equal Q star, then the partial derivation of the cost is 0 because it's the minimum. So we end up with Q square star plus CC divided by 2 equals 0. And this means that Q star equals 2 times C times D. No, sorry, 2 times CO times D divided by CC. Okay, so this is already known from previous semesters. I just repeat it as a courtesy. So the total cost equals Y of Q star and if we perform this, we just need to put our value of Q star in the above equation. Well, we can add demand times the price. It's no problem. demand times the price, and then we have it all. Okay, so it's demand times the price plus the CO divided by Q star plus Q star times CC divided by 2. Okay. This dP is just a constant, so usually I don't paint it, but let's paint it. It's just a purchase, okay? Demand is the purchase cost. So we know the total cost is it follows this this equation. Any questions? If you want to do it more slowly, you have the videos in the internet. So if you decide that you're going to use the manufacturing model, the only difference is that your carrying cost per unit is going to be multiplied by excuse me, by a factor, okay? And the whole y equation, y of q, is going to be a little bit different, just slightly different. The CO times T divided by Q is similar. The setup cost is the same because you have the same cost, but the carrying cost is going to be slightly different. So you have your Q divided by 2, so the average demand times CC multiplied by 1 minus R divided by K plus dP. Okay. If you perform again the partial derivation, is this is CO times T divided by Q square plus CC 1 minus R divided by K divided by 2. If Q equals Q star, then the derivation of Y, partial derivation with Q equals Q star is 0. Then we just CO times D divided by Q star square plus CC 1 minus R divided by K by 2. So the Q star equals square root of 2 times CO times D divided by CC 1 minus R divided by K. Okay. And the total cost is again just demand times the price plus D times CO divided by Q star plus Q divided CC K minus R times Q star divided by 2K. Okay, you can do that more slowly if you wish. Okay, so with these two models, we see an example. How did I visualize it before? Wait, let me go up. So now we see an example. An item has a yearly demand of 2,000 units. The different, so demand is known, the different costs in respect to make or buy are as follows. Item cost per unit, buy or make at €8, €5. Procurement cost per order, setup cost, €120. If you buy, you have a procurement cost. If you make, you have a setup cost. This is €60. Annual carrying cost, items per year is €1.6, and here is €1. And production rate per year equals 8,000 units. So what is the best option? Determine the best option. Buy in the buy option, D is 2,000 units. Okay. CO is €120 per order purchase, and CC is €1.6 per unit per year. So we have seen that Q star equals 2 times COD divided by CC. If somebody is asking in the 7th semester if it's enough to know the formula, the answer is of course no. Okay, so you need to come to this formula, because probably in the exam, if I ask this in the exam, I will change this function. Okay, so the function will be a different one. So you need to be able to perform the derivation and find the minimum of the function. Okay, this is 2 times 2,000 times 120 divided by 1.6. This means 148 units after rounding. Okay, the total cost E sub k of buy, this is a buy, okay, equals D times price DCO divided by Q start buy plus Q start buy times CC divided by 2. This means 2000 times 8 plus 2000 times 1.2 divided by 548 plus 548 times 160 divided by 2. And this is euros 16,876.36. Okay, so that is the buy option, 16,800. All right. Any questions? So the make option, a little bit more difficult. Here we have a CO equals 60 euro setup. R equals 2000 units per year. CC equals 1 euro per unit per year. And K equals 8000 units per year. So Q start make equals 2 times CO times R divided by CC times 1 minus R divided by K equals 2 times 60 times 2000 divided by 1.0, 1 minus 2000 divided by 8000. And this equals 566 units approximately, a little bit more than the buy option. And then the cost of buying equals D times P plus D times CO divided by Q star M plus CC K minus R times Q star M divided by 2K, and this equals 2000 times 5000 plus 2000 times 60 divided by 566 plus 1 times 8000. I'm just substituting, okay, times 566 divided by 2 times 8000. And this equals euros 10,424.26. So the cost of making is smaller than the cost of buying. because the cost of buying is bigger than the cost of making, then the company, the firm, should make the product. Okay? Any questions? Okay, we go straight without questions. Your decision. We make a little break and we continue in a couple minutes. We continue with the last way to approach this make or buy. Last way is not an economic analysis, it's not a simple cost analysis, is to make a break-even analysis. Okay, I assume you know what a break-even analysis is, so I just go through it and make an example break-even analysis. If somebody doesn't know how to find the break-even point, please contact me privately. We can go through it. When we perform a break-even analysis, what we do is we paint the quantity, okay, Q, and we paint the amount of sales, the euro sales, and then we have a curve. The more we sell, the more quantity, the more sales. Okay, so this is the first curve. Let me go a little bit slower with colors so it's easier to understand. So sales is the blue one. The more we pay, the more quantity, the more the total cost. Okay, so basically the total cost is TC, and this is going to be, let's say, Rosa. And so the difference between the total cost and the sales is the profit. Okay, so whatever we have up here, this area, is going to be our profit. We have some fixed cost. Fixed cost that no matter what we have, okay, and then we have some variable cost. And the sum of fixed plus variable cost equals the total cost. Okay, so whatever we have here below our curve, here we have more cost than sales, so this is our loss. Okay, this is from the first semester. Okay, this is just 101. So we have our B point, which is the break even. The C is a quantity, and the A is whatever sales we have. So the nomenclature here, TC is the total cost, as I said. FC is the fixed cost. DC is FC plus variable cost, VC. Okay, VC is variable cost. B is the intersection of TC and sales. And A is the break even. Okay. Break even sales, and C is the break even quantity or break even point. Okay. So the break even point, BEP, is FC, fixed cost, divided by selling price per unit minus the variable cost per unit. This is the formula. This is just, it comes from solving the equation DC equals sales, DC equals sales, okay? FC plus VC equals sales. And then just finding the BEP that solves this equation. Okay. Let me write it correctly. I mean, it's correctly, but with just the same variable cost per unit, so that it looks pretty. Okay, so this is the break-even point. Is the quantity that equalizes the total cost and the sales. Okay. An example, imagine a firm of TV buys a TV cabinet for 500 euros each. In case the company makes it within the factory, the fixed cost would be fixed cost would be 4 million euro, and the variable cost would be 300 euro per unit. Should we make or buy? Demand is set as 1,500 units per time. Okay, so the solution is that the selling price per unit is equal SP equals 500 euro. The variable cost per unit VC is 300 euro per unit, and the fixed cost per unit FC, no, not per unit, fixed cost is fixed cost. FC is 4 million euro. So what is the BEP? 4 million divided by 500 minus 300 equals 20,000 units. Okay. Since the demand, what is the interpretation? Since the demand is units, 1,500 units, is less than BEP, the company should buy the cabinets, because if I produce them, I am making a loss. Okay. Questions? Okay, and I'm going to give you one exercise for you. Okay. There are 3 alternatives. There are 3 alternatives available to meet the demand of a particular product. They are as follows. A, manufacture the product by using process A. B, manufacture the product by using process B. Or C, buying the product. The details are given, okay? Cost element. So manufacturing with process A, manufacturing with process B, or buy, okay? Fixed cost per year. 500,000, 600,000. Variable cost per year, 175, 150, and purchase Price per unit, 125. So annual demand is 8,000 units. Should we make or buy? Okay. For you to solve. All right. Just as a consideration, a personal consideration, whenever I had the option of make or buy, I was always, before looking at the numbers, I was always 90% for make and 10% for buy. The reason is that make keeps the jobs. So whenever you're working in a factory, you always fight to keep the jobs in the factory. You don't fight, you don't stop fighting if you let your arms down and you start buying the product to somebody else. You are going to be jobless at some point. So always fight to keep the jobs at home. Always try to make yourself. Keep the knowledge, keep the know-how, keep the people busy. Okay? And this is the most important task that you will have if you ever have some responsibility. Keep the jobs, keep the people busy. Okay. So, any questions? Gibt es Fragen zur heutigen Vorlesung? No questions? Okay, well then, ich werde alles hochladen für diejenigen, die nicht dabei sein konnten. Wie immer auf der Webseite. Ich denke, es ist besser, wenn ihr euch anmeldet auf dem YouTube-Kanal, weil dann kriegt ihr alle Änderungen mit. Die heutige Vorlesung war wichtig für die Prüfung, also bitte richtig gut verstehen. Wenn jemand Fragen hat, einfach schießen, okay? So, ich wünsche euch eine restliche schöne Woche und bleibt bitte gesund. Ciao.